Welcome, everybody, to our RSA Conference 2021 presentation, What's Old is New, Hybrid Security for Microsoft Azure and On-Premises Tech. My name is Matthew McCourt. I'm a director at Mandiant FireEye in our Security Transformation Services team. With me is my colleague, Mike Barnes. Mike, do you want to say hello?
Yeah, thanks, Mac. I'm a principal consultant on the Security Transformation Services team at Mandiant.
All right, so let's get started. We have a lot of content here, and we certainly want to dive right in. So why did we put this presentation together? Attackers today are following the data, right? And they're following the availability of data. And as many organizations are moving to the cloud, they still have their on-premises architecture. And sometimes we find that it's a challenge for organizations to manage security and visibility for both their on-premises Active Directory and their identities and data that's resident maybe in Azure Active Directory or Microsoft 365. So we put this presentation together to highlight what are attackers doing that still allow them to be successful in targeting on-premises Active Directory, but also now what are they doing for these hybrid environments where organizations have a footprint still on-prem, but also in cloud. So we will spend some time just looking through some of the common attack techniques, but most importantly, we will spend a lot of time looking at some of the common defenses that organizations can leverage to secure their hybrid identities. Throughout this presentation, we will be doing a compare and contrast with on-prem to cloud. And when we say cloud, we're talking about Microsoft Azure and Azure Active Directory. But no, most of the presentation is weighted more on the cloud side because a lot of what we will talk about from the on-premises side has already been discussed in many conferences. A lot of the material here is more relevant to what can you do to secure your cloud architectures. So before we dive in, if you have any questions as we go through, please post in the chat. We are happy to address those as we go through the content because we will be going kind of fast to get through all of our material. This is just some clarifying terminology, some terms you will hear us use throughout the presentation. So this slide just represents a comparison to what you might be used to hearing from the on-prem world to what is the correlating term or definition in Azure Active Directory. So let's start and talk about privileged accounts and roles. I'm going to start really focusing back, to the old school on-prem Active Directory. This is still relevant today. The graphic here represents groups, right, that are highly privileged groups that exist in on-prem Active Directory that attackers will commonly target when they're doing reconnaissance. These are the groups that house the accounts that pretty much have the keys to the kingdom. Some challenges that we find with organizations is they only focus on those kind of in the top portion of this graphic, enterprise admins through your schema admins and accounts that have the ability to access domain controllers. The takeaway here is there are other privileged groups that are buried within Active Directory that attackers will also target when they have access to on-prem. What are some other interesting privileges that we see? So this example right here, we see an account that has been delegated permissions at the root of the domain for replicating directory changes and changes all. An attacker, if they were able to compromise this account, could do a directory sync, a DC sync, maybe sync the entire Active Directory database and then use that for further compromise of accounts and lateral movement and pivoting. We also see accounts that have been delegated specific permissions, right? This is an example of account via user rights assignment that actually has the ability to run as system on a domain controller. This account may not be in the domain admins group per se, but this account in and of itself, based upon these permissions, is highly, highly powerful and privileged and one that could be overlooked by organizations. We also have an example of here, this is an example that we found as part of an Active Directory security assessment, where every user in a domain had the ability to modify permissions for this Fates Warning security group. And if this was a highly privileged group, once again, this is a quick way for attackers to further compromise. This is probably one of my favorites now, is looking at accounts and groups that have the ability to edit and modify existing group policies. This is what we see ransomware attackers do on a very frequent basis to push out encryptors and to really create havoc to a large scale of endpoints within an environment. So these are all kind of interesting permissions that are sometimes buried within on-prem Active Directory. So now let's take a look at it from the Azure Active Directory side. Out of the box, Azure Active Directory, you have 60 built-in privilege roles in Azure AD. Now, not all of these are highly, highly privileged, but we will kind of highlight some of the more interesting ones from our perspective. What is very important, though, for organizations to understand is when they have Azure Active Directory, they might also have infrastructure in Azure, which is referred to as Azure resources. So this could be virtual machines, storage accounts, web applications, things like that. There are separate roles which actually provide the ability to manage and to provide administrative permissions for resources. These are about 70 roles by default. You can also create custom roles. But really I want to highlight here is that Azure AD roles and Azure RBAC, role-based access control roles, are different and they do different things. We will kind of highlight that as we go through the presentation. Also of importance, if you're used to logging into the Azure portal, right, to look at all of the different roles and accounts that are assigned various roles, not all of them are visible in the portal. So this directory synchronization account role is highly, highly privileged. This is a role that one of the connector accounts, when you create a bind between on-prem to Azure AD, gets assigned this role, right? So if you're looking in the Azure portal, you might not see accounts assigned this role, but lo and behold, with the PowerShell command that we have in the bottom right corner there, you can actually enumerate and get more clarity over accounts that are assigned hidden roles, because you can still actually use those even though they are hidden. What's also of important here is monitoring and having good visibility when accounts are assigned roles, even roles that may be hidden within the classic portal. So this slide is kind of a parallel to what we talked about from on-prem Active Directory. This shows from the Azure Active Directory side, what do we consider to be those very, very highly powerful privilege roles? And Mike will also talk about these a little bit further in the presentation. The ones at the top here are those roles that have password reset permissions for various accounts and tenants, and the roles at the bottom have specific permissions, if you will, of interest that we highlighted there. Also, what is important that a lot of organizations have not yet started to do when they move to Azure Active Directory is monitoring. Organizations have gotten really good at monitoring on-prem AD for, if someone's added to a domain admin group or a group of interest, but not all, it's not common though that organizations are now doing this in Azure AD. So it's very important for organizations to start monitoring some of these very, very privileged and interesting roles in Azure AD when a user is added or removed from that. So now we're going to talk about the different set of roles in Azure. These are the RBAC roles on resources. So remember, a resource could be a virtual machine, it could be a storage account, it could be a web application, a database that resides in an Azure tenant. We always get questions from clients about, they're often confused about what does Azure RBAC mean? If I assign somebody one of these built-in roles in Azure, what kind of permissions is that account assigned? So we have a formula here that kind of breaks that down and clarifies that. So the first part of this is related to the scope. The scope, you could assign, a permission at the root, for a specific subscription, or for a specific resource. The next part of the equation is, who am I assigning the permission to? Is it a specific user? Maybe it's a group, maybe it's a service principal, or maybe it's an application. And we will talk about those a little bit later. And then third is, what kind of permissions are we assigning? Are we giving them full contributor, reader, owner? And they can pretty much have, full control over that resource, or is it just a read-only type role? So once you kind of understand that, you can kind of start to get some clarity about what are all these RBAC permissions and roles actually doing. What's also of important, this is why this is in the interesting privileges slide, is sometimes organizations don't quite monitor or know the scope of accounts that have elevated permissions or some sort of role assigned at the root or for a specific subscription within their Azure tenant. So this shows an example of how you can actually download these role assignments and get some more clarity over where are all these RBAC permissions assigned, because they can be assigned in a multitude of places in Azure. And this often creates confusion for organizations just trying to get some clarity here. There's also custom roles, which you can do in RBAC to add even more confusion here. I think one of the things that we want to highlight here is when organizations create custom roles, just like in on-prem, when they create custom security groups and delegate, right? They want to have a good process, documentation, and a good methodology around why do we create this custom role? Where are we assigning permissions? Is it for a resource? Is it for a higher level root or subscription? And then who is assigned permissions for this custom role. This is the other example here in the slide is a PowerShell command, which you can use to get more clarity and to kind of bring things all together without having to go to different places in the Azure portal to figure all of this out. So now let's transition and talk about, what are attackers doing from the recon and privilege escalation perspective from both on-prem and in Azure Active Directory. So I'm not going to spend a whole lot of time here, but as I mentioned, if you have questions, please post in the chat. We're happy to clarify these or any questions that you have. But this is a classic model that we see with ransomware cases. Unfortunately, at Mandiant, we support many, many ransomware cases every week with clients. And this is kind of the path that attackers kind of follow when they gain initial access. Maybe it's through a phishing email. They're going to do some sort of recon to understand where they are in the environment and where do they want to go next, right? So they might use open source tools such as Bloodhound, this might run some PowerShell commands, or just invoke some old school, commands from a command prompt to figure things out and then determine where they need to go next. Then they will oftentimes invoke Kerberoasting, which is targeting non-computer accounts with a service principal name. And with those accounts, you would get a ticket. With that ticket, an attacker may be able to brute force a password for a privileged account and use that for further escalation. Then there's, of course, lateral movement using the classic built-in Windows default pathways that are always there, always exist. And we have some examples here on the slide. Oftentimes we get asked by clients, how did the attacker get the clear text password for this account? We had a very long password. How did they get it? The three common ways we see. The first graphic here on the left is Credential Manager being enabled on a Windows 10 or above endpoint that allows you to get credentials if that's not turned off. You can turn that off through a group policy. So we always recommend clients do that. The second there in the middle is wdigest authentication. Which, while it's disabled by default, we oftentimes see attackers will re-enable wdigest. And with that, they don't need to reboot an endpoint. They just need to wait for more accounts to authenticate. Then they get the clear text password in memory. The third is an interesting one. It's related to Kerberos authentication. So if you're on a Windows domain join endpoint, you log in and the domain controller is not available, it can't be contacted at the time. Kerberos will store the password in clear text in memory until a domain controller can be contacted. So if we think about times in COVID, right, when users are working remotely, they might be logging into their work laptop at home. They're not connected to the VPN. This is a low-hanging fruit that attackers could use if they have access to an endpoint. So what does this look like from the Microsoft Azure side? You don't necessarily need to have valid credentials just to get some interesting information about an Azure tenant and the configurations that exist. So this slide just shows some various ways using some of the APIs and URLs. All you need to do is just have the right domain name, registered domain name, and you might be able to get like the tenant ID, which we have highlighted in red in that first example. I think more interesting though, you can actually determine what type of authentication is this tenant using? Are they using ADFS, Active Directory Federation Service? So we see an example of that in the bottom left portion of that graphic. And on the right, we see a tenant that was configured for just local Azure Active Directory. It could also be indicative of password hash synchronization being configured. So you can just get some interesting information just from some of the URLs that are available. This slide, really represents that there's a lot of tools out there. There's even more so than we have listed since we put the slide together. Just a lot of ways to kind of automate recon with Azure Active Directory and Azure using either an unauthenticated method, or if you have valid credentials, obviously that's even better, right? Because you can get more data, more contextual information. So say that I do have valid credentials and I'm able to log, maybe I got these from on-prem and maybe the environment does not require multi-factor authentication. If I have a valid username and password, I can log into the portal. And even though this might not be a privileged account, which this example shows that I logged in with a non-privileged account, I can still enumerate users, I can see resources, I can get some great information about a tenant for further targeting. Now, the good news is you can actually turn this off. So there is a feature where we recommend to clients all the time that you turn off the restrict access to Azure AD portal, change that from a yes to a no, and you kind of see where it says you do not have access. That's a great way to stop, an attacker that's used to the graphical interface. Those that are going to use PowerShell, though, even if you turn that off, it doesn't take away their ability to still query some general contextual information about an environment, just as you can with on-prem Active Directory, right? This is no different. It's this read-only access, if you will. So how do attackers then pivot from on-prem to Azure AD to really, compromise an Azure Active Directory tenant? This is what we at Mandiant refer to as vertical movement. So this is an example of a conditional access policy you see there on the right, where MFA is required all the time for all accounts, except when initiated, except when the authentication is sourced from a trusted IP. This could be a public IP block assigned to an organization or, as part of like their VPN pool or something like that. So once again, This is a common way we see attackers that get valid privileged credentials on-prem, maybe via phishing or other means. Then they use those credentials to pivot up into Azure Active Directory. Mike will talk about this in more detail from some of the best practices, but we are constantly recommending to clients if an account is privileged on premise, it should not hold privileges in Azure. There should be separate cloud-only accounts that have those permissions. And for accounts that have some of those privilege roles that we just showed earlier, they require MFA all the time, regardless of where they're being used to authenticate from. This example is the perfect storm, right? That's kind of our theme here, is the perfect storm of bringing everything together. Remember earlier I said Azure Active Directory roles and Azure RBAC roles are separate, right? They provide permissions for separate components. Well, here is the perfect storm of if you are a global administrator and that option that you see there in the bottom left corner is set to yes, you can then assume the role of user access administrator in Azure RBAC, right? So with that, I then have the capability to delegate access to specific resources. Sean Metcalf wrote a great blog about this about a year ago. Highly recommend you go to adsecurity.org, and we have a link in our reference slide about this specific attack path. But with this, you can actually assign yourself, say that an organization has a VM running in the cloud that's a domain controller. With this user access administrator role, I can then start with a global admin in Azure AD, move to a VM resource, and I could potentially log into that resource, dump credentials, and then go from cloud to on-prem, right? Vertical movement. So this is something that organizations need to be aware of and really understand these roles and permissions that are assigned to accounts. The last portion here that I really want to highlight, this is something that we saw come to fruition last year, is application objects and service principals in Azure Active Directory. So you can see various applications that might be registered in a local tenant, either through the UI or PowerShell. Applications could be some custom apps that an organization has, or there could be some third-party app that's now integrated that they actually install directly into a tenant. Those are actually represented as an object in Azure Active Directory. What's interesting, though, is for an application to work, in order for users in your Azure Active Directory to be able to authenticate and use that application, a service principal has to be linked. If you look at service principals that exist in Azure Active Directory, you are going to see a lot of them, especially if you're using Microsoft 365. Because Microsoft 365, if you're using Teams, Exchange Online, SharePoint, the actual apps are actually hosted by Microsoft in their tenant, if you will. But each tenant that an organization manages will have service principals associated. Service principals are that glue that binds an application to Azure AD for authentication. The thing to be aware of with service principals is they can also be used by attackers. Service principals or applications could be assigned specific permissions. Maybe an application has permission to read all email or to read all files in SharePoint. And service principals and applications can also have keying materials associated. When I say keying materials, I'm talking about a password or a certificate. So the perfect storm kind of came together at the end of 2020, still seeing this into 2021 with an attack group that we refer to as UNC 2452. We have a detailed white paper that we at Mandiant FireEye put out. It's on our website. It's free. So please go there and take a look, because we actually do a deep dive of this entire attack technique I'm going to talk about in like 30 seconds, but it's all there in the paper. So if an attacker is able to compromise an account, maybe it's an on-prem account that unfortunately is synced with permissions in Azure Active Directory, they could then potentially add a certificate to an application or service principal and basically log in as that application or service principal and piggyback on those permissions to maintain persistent access to data. It could be to email, to files, anything that might be present in the tenant or maybe even in Microsoft 365. Why are attackers using service principals? You can't correlate or you can't require multi-factor authentication for a service principal login. And service principals are not governed by conditional access policies. So if you have these nice guardrails in your conditional access policies, service principal logins do not abide by those. So this is what we are seeing attackers do. If you think about it, if an organization thinks they have a compromised account in Azure Active Directory or a large scope of accounts, they're going to reset the passwords, right? They might require users to re-register multi-factor authentication devices. They're going to do all these great things. And if they're not taking a careful look at their applications and service principals, the attacker, even though the organization does all this great stuff, will still maintain their access. How do you connect as a service principal? Well, Microsoft actually has very detailed step-by-step guidance at these references below to kind of walk you through how that's done. So here's an example where we did it in PowerShell. We created a service principal, linked a certificate to that, then linked the service principal to an application that had specific permissions, maybe to read files, let's say in SharePoint. SharePoint Online. Then we logged in just with that certificate that we linked to that service principal. The great news is you can actually monitor for these logins and sign-in logs, right? This information is available. So please start correlating and baselining your service principal sign-ins. You can also do correlation, understanding when the service principal ID is, what application is that linked to, and get some more contextual awareness there. So I'm going to turn it over to Mike, who's going to, I think I probably gave everyone a headache going through this pretty fast, but Mike has some awesome defenses here for both the on-prem and Azure Active Directory side that we will be going through.
Thanks, Matt. I'm going to talk about some defenses for privilege escalation hardening when applying to the cloud. When on-premise, we are generally recommending that organizations identify SPNs, as Matt mentioned, looking into their wdigest settings and utilizing the protected users group. And we often see attackers utilizing the SMB version 1 to laterally move around environments, but also take advantage of the vulnerabilities that exist in that protocol. When it comes to privilege escalation hardening in the cloud, this is where we're going to begin to recommend that organizations understand password reset privileges, be utilizing conditional access policies, utilizing tools such as privilege identity management, the cloud-only accounts that Matt mentioned, and then also the same concept holds true as on-premise as it does the cloud, is attempting to utilize privileged access workstations for controlling Azure Active Directory. This is a tweet that was presented by Andrew Robbins and the team at Spectre Ops, also Ryan Hausneck. They developed a password reset matrix and posted it publicly on Twitter. And I think it's a great example of the community taking the time to promote their research and then influencing Microsoft to make official documentation around it. In their research, they discovered that the privilege authentication admin has privileges to reset passwords for the global admin. And this was properly noted by Debug Privilege that you should be protecting your privileged authentication administrators just like you would your global administrators. When it comes to conditional access policies, there's many routes that you can take to properly protect Azure Active Directory. These are some recommendations that we give to clients to be building conditional access policies, particularly for those highly privileged Azure Active Directory roles. Most notably, you always want to make sure that you have 2 global admins that are break glass admins that are not subject to any conditional access policies. But what you should be doing is monitor for their login activity and have your security operations center always alerting when they see these accounts in use. One thing that many organizations may not be aware of is that if your admins are logging in to Azure Active Directory at least once every 90 days, if you're not setting a sign-in policy or a session policy, that they will never be prompted for a password if they are logging in at least once every day from the same workstation. So this is where you want to make sure you're creating conditional access policies that include session policies or sign-in frequency policies. We could get into deep dive on blocking legacy protocols, but we're advising some strategies here of short-term, mid-term, and long-term wins to be able to remove the use of legacy protocols in your environment to make sure that modern authentication is used. And lastly, you want to start to work towards utilizing compliant devices to access your Active Directory specifically for those administrative roles. This could begin to move into the realm of zero trust, where you are establishing trust of an endpoint and an identity based on the health of that endpoint and also the health of the identity. When it comes to disabling legacy authentication, there's kind of 3 main ways that you can go about doing so. And you can see here from moving from left to right that conditional access policies are generally the easiest way to enforce the blocking of legacy protocols, but it can also be done via an exchange authentication policy or at the mailbox level. It's important to note that conditional access policies trump both of these methods of blocking legacy authentication, with the diagram on the right showing the workflow of when each control is enforced. And you can see there that the Azure conditional access policies will trump an authentication policy or a mailbox policy if that's where you're blocking legacy authentication. As Matt mentioned prior, we always recommend to be utilizing dedicated cloud-only accounts for managing Azure resources. This is noted by the UPN at the viral tenant name on Microsoft.com. You may get some challenges that this is impossible, but it is. That if you do have system administrators or developers asking for exceptions to bypass MFA or bypass the login from trusted networks. This is where you want to be making sure you're creating an enterprise application or a service principal and properly baselining the login activity, as Matt mentioned earlier. When utilizing federated identities from on-premise to cloud, this is where we recommend not to do that. This is where we see that form of vertical movement as noted by UNC 2452 and utilizing the Golden SAML attack. They were able to bypass MFA and log into the environment where there's been highly privileged roles that were syncing from on-prem. Also, you want to make sure that your cloud-only accounts do not contain an immutable ID. This does happen, albeit it is very rare. And we also provided a short scriptlet to be able to identify those accounts. So if you do identify any of those accounts where a immutable ID exists on a cloud-only account, it is important to note that those accounts are susceptible to a Golden SAML attack, in that once identified, you want to be recreating those accounts as cloud-only accounts to remove that immutable ID. The combination of privilege identity management plus conditional access policies is probably the best way to prevent privilege escalation. That ideally, you don't want to have an administrator carrying their privileges all day, every day, that they should be doing it in a just-in-time format. Also, try to introduce the FIDO2 protocol for having your admins log into the Azure Active Directory environment. This is a great concept because it kind of mimics building access. When we go into the office every day, or we used to go in the office every day, we would commonly badge into the building, badge into the elevator that will let us to a certain floor, and then potentially badge into our office. And nobody complains about that, but everybody complains about passwords. So that's where the items like YubiKeys can really become beneficial to administrators to efficiently escalate their access and perform their daily duties. And here we provide some examples of conditional access policies to utilize to prevent the escalation of privileges when in the Azure Active Directory environment. This framework here is just a sample framework of how an organization could begin to use the combination of privilege identity management plus conditional access policies to enforce a strong posture when asking administrators to either elevate their privileges or be administrating the environment. Lastly, the concept of privileged access workstations does apply to Azure AD as well. That this is something that started with the on-premise, but has also been included in cloud. So one challenge we get is, do my administrators really need to be carrying around two devices, or do they need to go to a physical device? And that's not always the case. One model that we've seen utilized is having your physical device or your physical laptop be the privileged access workstation with a strong compliance policy tied to it, and then a virtual machine inside that privileged access workstation, which we would call the productivity virtual machine. And that's where your admins would log in with their day-to-day accounts and to do their internet browsing in their email, daily email review. And that could hopefully remove the barrier of having to utilize two workstations. You're going to want to enroll that physical device into Intune and apply a baseline to it. Microsoft has provided some secure workstation baselines that can be applied to the workstation and then also be applied to Intune to be marked as a compliant configuration. And then this can be utilized in a conditional access policy where if trying to access the Microsoft Azure Management Cloud application, that it must be done so, say, from a trusted network, from a compliant device, and require two-factor when needed. And on the right, we're providing some of those highly privileged roles that exist within Azure Active Directory that this should be applied to. Next, we're going to be talking about lateral movement hardening when it comes to the cloud. Again, starting with on-premise, we're always advising organizations to understand the Kerberos ticket process, understanding user right management groups with on endpoints and applying those via group policy, always deploying out laps, utilizing strong Windows firewall configurations to block those management ports such as WinRM, RDP, and SMB, common protocols we like to see attackers take advantage of. And then lastly, again, SMB version 1, that hopefully this will slowly be decommissioned across organizations as time goes on. How does lateral movement hardening apply to the cloud? This is where we like to focus on mobile device management and really what's the new tier 0 when it comes to cloud. And we'll talk about some of these concepts. Before getting into that, it's really important to understand the Azure AD device join types, that when registering a device or joining a device to Azure AD, it could take on one of these 4 columns. And most notably, we'll be kind of focusing on hybrid Azure AD joined and Azure AD joined, where on the right, Azure AD registered is most notably like the devices that are our tablets and our personal cell phones of iOS and Android. When it comes to mobile device management, it's important to note that users can register their own devices by default, and they can register up to 50 devices on-prem. On Azure AD. And if you think about it, what an attacker may want to do is compromise some credentials, join a device separate from the user, and then make that device compliant to gain access in an environment. So we've seen attackers take this path where instead of staying resident on a user's laptop, that they'll just compromise those credentials and then join their own device and make it compliant if they need to satisfy some conditional access policies. Also, you want to be making sure you're protecting access to the mobile device management platform. So this isn't only Intune, but this is also platforms like Jamf and AirWatch, that once an attacker gains administrative privileges to a mobile device management platform, it's pretty much game over. They've achieved remote code execution on the endpoint to conduct their attack. And even in a distributed environment, like we are in the COVID or remote access, that if they're on a mobile device management platform, they can begin to encrypt those endpoints by triggering a deployment of their payload to all the distributed endpoints registered to MDM to conduct kind of a distributed ransomware attack. We admittedly have yet to see that, but it's important to note that it may be possible. And also you want to be checking the MDM APIs that are available from the platform. We've seen our red teamers take advantage of APIs because they do not always require MFA. And this is one way they can escalate to their privileges on an MDM platform. One thing that a lot of organizations may not know is when joining devices to Azure AD, by default, the user that registers the device is automatically made a local administrator. So here we're documenting the way it looks on an endpoint to join it to work or school. You enter in the user's your own username and password. That will add you as a device within Azure Active Directory. And it even gives the user a pop-up saying, hey, you are going to gain administrative privileges. And as I log in again here, I will gain that local administrative privilege. So this is why it's important to not allow all your users to be able to join devices to Azure Active Directory if you want to have a strong security posture on your endpoint. Attackers are taking note of the local administrators as well as joining devices to Azure AD. And reason it is important to note is that when joining a device and logging into Azure AD, the device is given what's called a primary refresh token. And this is a long-term token that is stored on the endpoint and the token is given by Azure Active Directory once a successful authentication is made. So this is comparable to a ticket granting ticket. And the reason attackers are targeting this token is because they can take this token from a laptop and use it independently from the laptop that they compromise and authenticate as that device to Azure Active Directory. And within that token, it contains the signals that the conditional access policies have already been satisfied. So that's a way they are able to bypass conditional access policies. And there are proofs of concepts that exist of this attack when a user has local administrative privileges, as noted in the previous slide, that it is easy for users to have local administrative privileges. And even if they don't, and they are allowed to join devices to Azure Active Directory, that the attacker may do that on their behalf. One question we get a lot is, how do I do laps within the cloud? And right now, there isn't a Microsoft native solution that exists for assigning a local admin password on each endpoint. That this still requires Active Directory to be able to utilize it. There are some possibilities of achieving this through third-party endpoint management software, but as noted in this CloudBoy blog, that a combination of Intune plus Azure App Functions and Azure Key Vault, that they've documented a way that this could be achievable using Microsoft hosted services. And hopefully Microsoft takes note of this and makes a similar platform that is supported by Microsoft. Protecting tier zero is a little different when it comes to protecting tier zero in on-premise. On-premise, that we're always thinking of tier zero being your domain controller, but now it's your identity providers like Pings and Oktas that are the new tier zero. And you want to be protecting those as you would a domain controller. You could think of these identity providers as domain controllers because they are providing the authentication, the authorization, and auditing for all your federated cloud apps. And once a user tends to log into these platforms, they begin to then gain access to all the assigned cloud apps that they've been given to by an administrator. So you can see here, it's kind of a double-edged sword that you're getting centralized management over your user base, but also once that user is provisioned access to multiple cloud apps, that if their credentials are compromised, that an attacker could log into these cloud apps and laterally move across each of those cloud apps. Also, we notice attackers targeting administrators of these identity management platforms to conduct their attacks, because ultimately, if they are an administrator, they could then provision their own account, or they could give another compromised users access to more cloud applications. So that's why we're noting that you want to be protecting your identity service providers, your cloud service providers, your MDM platforms, like you would tier zeros. Logging into those those platforms from trusted devices, compliant devices, trusted networks requiring MFA, because this is where attackers are beginning to focus their efforts on when it comes to cloud distributed environments. So that wraps up our conversation of securing the cloud and how our cloud concepts apply to on-premise concepts and vice versa. If you guys have any questions, please feel free to reach out to Matt or myself. Our contact information should be made available on the RSA portal.